This is 2009 FRQ number 5 in the non-calculator portion. All right. Let f be a function that is twice differentiable for all real numbers. The table above gives a value for f for selected points in the closed interval between 2 to 13. Estimate f prime of 4. Show the work that leads to your answer. So f prime of 4 is the derivative of 4, but I don't have an x value of 4. I have a 3 and a 5. So you then use the idea of slope. You do y2 minus y1 over x2 minus x1 to estimate the slope of the number that's in between. So for part A, f prime of 4 is equal to y2 minus y1 over x2 minus x1. That gives me negative 6 over 2. That's negative 3. And that's it. F prime of 4 is approximately negative 3. That's an estimate. Okay. Part B, evaluate this integral. So part B, evaluate 2 to 13, 3 minus 5 f prime of x dx. All right. So let's just take it a step at a time. It just looks really ugly, but it's really not that bad. So 3 is a constant. So if I take the integral, 3x minus 5 as a coefficient, 5. F prime now becomes f of x. Evaluate 2 to 13. And we plug in 13. 3 times 13 minus 5 f of 13 minus 3 times 2 minus 5 f of 2. Okay, that's 39 minus 5 f of 13 is 6 minus 3 times 2 is 6 plus 5 times f of 2. F of 2 is 1. So that's 39 minus 30 minus 6 plus 5. So that gives me a total of 8. Yes? 44. Yep. All right. And that's it. Okay. Use a left Riemann sum with subintervals indicated by the data to approximate the area between 2 to 13 of f of x. All right. So we want left Riemann sum, LRAM. LRAM means we don't use the last y value. Okay. So we don't use the last y value. All right. So for part C, my LRAM is equal to, okay, so the base is the difference between these two, so that's 1, times the first height, that's 1, plus the difference between these two, that's 2, times the height, 4, plus the difference between these two, 3, times the height, negative 2, lastly, the difference between these two, that's 5, times the height, 3, all right? Add them all together, you get 1 plus 8 minus 6 plus 15. So that gives me 23, 24 minus 8, that is minus 6, that's 18. That's my LRAM. Okay? All right. Suppose f prime of 5 equals 3, and f double prime is negative, which means it's going to concave down for all of x. All right, in between 5 and 8. Okay, so in this region right here, we're going to look at here. Use a line tangent to the graph of f at 5 to show that f of 7 is less than or equal to 4. Okay, so let's do that first. Let's find the tangent line. So to find the tangent line, I need the slope. I need the x and y value. I have the xy value. The xy value is 5, comma, negative 2. The slope, m, is 3 because it says f prime is 3. So my linearization, because it's a tangent line idea, my linearization is going to be y minus y1 equals m times x minus x1. And that's going to give me y plus 2 equals 3x minus 15, y equals 3x minus 17. Okay, that's my linearization. So I'm going to use that to approximate f of 7, right? So I'm going to take my f of 7 and go, okay, f of 7, plug it in, I get 3 times 7 minus 17, that's 21 minus 17, that's 4. So my linearization, my tangent line tells me that the value is 4. But because this graph is concaving down, anything that I tangent, I'm going to be overestimate. So the exact value has to be less than or equal to my linearization. This is my linearization, sorry, it's not the f function. So if my linearization says it's equal to 4, then the actual value has to be less than or equal to 4 because the tangent overestimates for concaving down. Okay, so that's the first part. Then the second part says use a secant line for the graph between 5 and 8 to show that f of 7 is greater than or equal to 4/3. Okay, so tangent line uses 1 point to find the approximation. What's the difference between that and secant line? Secant line finds 2 points. So now you have 5 and 8. So we're going to use the 5 and 8 to write my equation. All right, so right here. So first thing I want to do is I want to use these 2 points to write my equation. Basically what I'm trying to do is I'm trying to use this concavity. Here's 5, here's 8. I'm going to use that point, that line, as my secant line. And see how my line is going to be underneath whatever the actual value is. Whereas my tangent line up here is always above whatever the actual value is. All right. So this is the 5, this is the 8. I'm going to use those 2 points to find my slope first. So slope is y2 minus y1. Sorry, that's a 2. And then x2 minus x1. That's 5 over 3. And then now I'm going to choose any point. I'm going to choose just the first point. So y minus a -2 equals 5/3 times x minus 5. All right. So I'm going to plug in 7 to see what my value is. So y plus 2 equals 5 over 3. 7 minus 5. All right. So I get y plus 2 equals 5 over 3 times 2. I ran out of space. Y plus 2 equals 10 over 3. Subtract 2. Y equals 4 over 3. So if my tangent line value is going to be 4/3, notice how my tangent line value is underneath whatever the value actually is. So my actual value of 7 must be above the 4/3. So because my secant is below my curve, therefore the actual value is going to be bigger than whatever my secant value is down here. So let's see. So secant is below a concave down curve. Therefore, f of 7 is going to be greater than or equal to whatever my secant value is here, 4/3. Okay? All right.